Before answering any of the questions in the research summary section, read the passage carefully the first time, but always refer back to the passage when you are answering the questions. While you read the passage, be sure to highlight and make notes in the margin. Things like variables, conclusions, differences in experiments. And it's really going to save you time when you're answering the questions. Pay close attention to a few things. First of all, the purpose of the experiment. Second of all, the outcome of the experiment. Thirdly, experimental procedure used. Effects of altering the experiment. How the data is presented in the charts and the graphs. And then assumptions and hypotheses. Okay, so let's take a look at a sample passage here. A student investigated some of the factors that may influence the period of a pendulum. A pendulum consists of a mass hanging from a string so that it can pivot. Observe figure 1 here at the right. The period is the time it takes a pendulum to complete one cycle and swing out and back. The following experiments were conducted to test the variables which may affect the period. Okay, so first I'm going to do highlight that part, that last sentence there. That's what I'm going to be looking at in these experiments that are going to follow here. Okay, so experiment 1, a mass of 2 kilograms was hung from a rope with a length of 10 meters. The student pulled the 2 kilogram mass up to different angles. The student measured how long it took the mass to swing back and forth 10 times, and then averaged them to get the time for one period. So if we take a look at Table 1 is comparing angle and period. I'm going to circle that. And the few experiments that follow, they're going to vary a couple other different variables, and we're going to observe those in the data table. Experiment 2, experiment 1 was repeated, but the angle was held constant at 15 degrees, and the length of the string was varied for each trial. So for this one, the length of the string was varied for each trial. Notice the last one, they varied the angle and measured the period. Now they're varying the length and measuring the period. Okay, experiment 3, experiment 2 was repeated, but the length was held constant at 5 meters, and various masses were used at the end of the rope for each trial. So here you can see various masses were used. So that's the variable that this experiment's changing. And again, on your data table, you're going to see your column headings, one's mass, and then one's period. So we got 3 things that are being changed. Experiment 1, they were changing the angle. Experiment 2, they were changing the length. And then now in experiment 3, they're changing the mass. Okay, so let's go over some types of questions you may see. First type of question you may experience is a read the chart question. Read the chart questions are going to require you to understand and locate information on the charts and graphs. They could also ask you to compare the experiments to one another. The answers are usually located on the charts or the graphs in the passage. Here's a few examples of read the chart questions. All right, number 1 here. Which of the following best describes the difference between the procedures used in experiment number 1 and 3? So we're looking for the difference, and we're just looking at experiment number 1 and experiment number 3. Okay, at the bottom here, I have table 1, which is from experiment number 1, and I have table 3, which is from experiment number 3. So you can take a look. Experiment number 1, table 1 here, we varied angle, and we measured the period. Table 3, we varied the mass and measured the period. So let's take a look at our answers. Experiment number 1, they're telling us the length is varied. Right away, from table 1, length was not varied. Let's rule that one out. Letter B, angle was varied in experiment number 1. That's true. And then in experiment 3, the length was varied. That's not true, right? Experiment 3, we know the mass is varied. Letter C, the angle was varied. And then experiment 3, the mass is varied. That sounds good, right? Letter C. Let's just check with letter D. Mass was varied, and right away we can rule that one out because experiment number 1. Number 2, which of the following conclusions is best supported by the results of experiment number 1? This question is dealing with only experiment number 1. So again, at the bottom here, go back to table 1 in the passage, and we're looking at a conclusion exported by just experiment number 1. So experiment number 1 has angle and period. So we're looking for an answer that has only angle and period. Letter A, the angle of the pendulum impacts the period. Let's take a look at that answer. As we change the angle, we increase the angle. Look at our period. 6, and then it goes to 6.2, then it goes down to 6.1, then it goes a little bit more down to 6.0. But it looks like as the angle increases, the period pretty much stays the same, right? It's right around 6 with a little bit of difference. So the angle does not affect period. All right, so let's look for an answer that supports that. Letter A, the angle of the pendulum impacts the period. That one we could rule out. Letter B, the mass of the pendulum. Mass has nothing to do with this one. So right away, we could rule that one out. Letter C, the angle of the pendulum does not impact the period. That one sounds pretty good. Letter D, the mass of the pendulum does not impact the period. And again, D was asking about the mass. The mass is not studied in this experiment, all right? So we're not going to go with letter D. So the correct answer for that one should be C. Second type of question you're going to see are use the data table questions. These are similar to data representation questions, except these ask you to make inferences, draw conclusions, and then make predictions based upon the information in the data table. Okay, so let's go over a few examples that you may experience. Number 3, if a trial in experiment 2 had been performed with a length of 17 meters, the period of the pendulum would be closest to. Okay, first thing, without even looking at the answers, I want to look back at experiment number 2. Experiment number 2 had to do with data table 2 here at the bottom. So go back to data table 2 and look at how the length impacted the period of the pendulum. We can see we started with a length of 2, and we increased the length of the pendulum. Take a look at what happens to our period here on the right-hand side. It starts at 2.8, and it goes all the way up to 9. So the length is going up, and the period is also going up. All right, so we're looking for something with a length of 17 meters. Now 17 meters, if you take a look at trial number 7 and trial number 8, 17 falls right in here, right in between 14 and 20 meters. All right, so we want to look for an answer that would be right in here as well, right in between 7.5 seconds and right in between 9 seconds. So take a look at your answers. Letter A, 4.8 seconds. We can roll that one out right away because it's less than 7.5. Letter B, 7. It's less than 7.5, so we can rule that one out. C, 8.3. That's in between 7.5 and 9, so that one's sounding pretty good for now. And then letter D, 9.1. 9.1 is greater than 9.0, which was 20 meters in length. So D we can rule out. So the period would be closest to about 8.3 seconds. All right, number 4, according to the experiments, which of the following conditions would produce the longest period? If you take a look at all of our answers have an angle, a length, and a mass. Okay, so this one's asking us to sort of incorporate all 3 experiments into one. So let's start off with, go back to the data tables in Table 1. Table 1, we see that as the angle is increasing, the period doesn't really change. It always stays about around 6. So I'm just going to make a note over here. Angle goes up, and period does not change. Do this on the test as well. Make notes right next to the data tables and next to the experiments as you go throughout them. Data table 2, if you take a look, is comparing length to period. Okay, so we can see length is going up from 2 to 20, and then our period starts at 2.8, goes all the way to 9. So it looks like as length goes up, then the period also goes up for that one. Okay, and trial number 3, or experiment number 3 here, Table 3, you're going to see that mass is going to increase from 1 to 7 kilograms. In the period, we start at 4.4, we end at 4.4. The two in the middle are right around 4.4, 4.5. So the mass goes up. The period, again, doesn't change for that one. All right, so you can see the only one that's going to impact the period is going to be length. Okay? Angle and mass don't change the period. So what we want to do when we look at our answers, we want to choose one that has the longest length of string because we want the longest period, right? So we don't even care about angle and we don't care about mass. I'm just going to ignore all those and all these because they have no impact at all on the period. Okay, so all I need to look at is the length. A is 5 meters in length, B is 8 meters in length, C is 5, and then D is 10. So the correct answer would be D. And again, rule out the fact that angle and mass don't impact it. So it doesn't matter what angle you guys drop it at, what mass you use. We're looking at the length of the string. All right, the third type of question you're going to experience is a graphing data questions. You're going to have to be able to transfer information from the data tables in verbal form to graphic form or vice versa. Okay, so here's a question. Number 5, based upon the results of experiment 1, which of the following graphs best shows the relationship between the period and angle? Again, look at table 1. Table 1 was the one where you had angle and period. So you can see angle goes up, the period doesn't change. So we want to look for a graph where the angle is going to increase, but the period's going to stay exactly the same. So right away, let's go ahead. Letter A can be ruled out because notice how the period is increasing as the angle is increasing. Letter C can also be ruled out because the period's decreasing as the angle is increasing. So now we're down to B and D. Letter B, think about what's happening in the period. The period, if we were to put a number on here, maybe like 5 or whatever it may be, the period's staying the same, but the angle is increasing. Okay, so letter B is the correct answer. Letter D, you can rule that out because your angle would be staying the same, but your period would be increasing. Okay, and number 6, which of the following graphs best shows the relationship between string length and period? This one's dealing with only experiment number 2, length and period. So go back, look at table 2. Table 2, we had a relationship between the length of the string and the period. And we found that length of the string is going up, the period is also going up. So L goes up, period goes up. So we want both variables to increase. Let's try to roll a few of these out. Letter A, we got period on our y-axis, length on our x-axis. Notice how for the second part of the graph, the period decreases as the length is increasing. So right away we could rule out A. B, it looks like the period's actually decreasing as the length is increasing. So we could rule letter B out. C, length is increasing, and then the period's also going up. So C could be an option. And then D, the period, if, again, think about putting a number on here. The period would be staying the same, but the length would be increasing. So the correct answer for that one would be C, because the period is increasing and the length is increasing. In conclusion, these questions will be the most common on the science section of the ACT. As long as you can understand relationships by looking at tables and graphs and predict additional information, you will have lots of fun on the section on the science test.